Hello and welcome. Today, we're diving into something surrounding us more and more, ubiquitous sensing. Think of it as the merging of our physical world with the digital, powered by countless tiny sensors. They're everywhere, in our environment, our cities, even on and in our bodies, constantly collecting data. It's not just about having more sensors. It's about having smarter, smaller, and more connected ones. So what makes this possible? At its heart, it's a blend of sciences. Materials science gives us new materials, flexible and sensitive. Physics and chemistry help us understand how to detect things like light, pressure, temperature, or specific chemicals at tiny scales. Miniaturization, using techniques like MEMS and NEMS, lets us shrink sensors down to incredible sizes. And biotechnology allows us to use things like enzymes or DNA for very specific biological sensing, crucial for healthcare. But science is only half the story. Engineering brings these ideas to life. This involves designing and building the sensors efficiently. A huge focus is on low-power electronics because many sensors need to run for a long time on batteries or harvested energy. Then there's wireless communication, getting the data from the sensor using things like Bluetooth LE or specialized IoT networks. Energy harvesting is key too, finding ways to power sensors from light, vibration, or heat, eliminating the need for battery changes. Finally, engineers develop algorithms, often right on the sensor or nearby, to process the raw data, filter out noise, and combine information from multiple sensors to get a clearer picture. It's all about integrating these sensors into larger networks, like the Internet of Things. Where are we seeing this already? Wearable tech is a big one. Smartwatches tracking our steps and heart rate. Smart homes adjust lighting and temperature, while smart cities monitor traffic and manage services using sensor data. Environmental monitoring relies on vast sensor networks to track air and water quality. In factories, industrial IoT uses sensors for predictive maintenance and optimizing production. Healthcare is being transformed by remote patient monitoring and early disease detection. Even agriculture benefits, with precision farming using sensors to check soil moisture and crop health. Of course, it's not without challenges. Keeping these tiny devices powered, especially in remote places, is tough. We're generating enormous amounts of data. How do we manage it and find the meaningful insights? Security and privacy are huge concerns. We need to protect this sensitive data. Making sensors cheap enough for mass deployment is another hurdle, along with ensuring they stay accurate and reliable over time, sometimes in harsh conditions. Looking ahead, the future of ubiquitous sensing is exciting. Expect even smaller, more integrated sensors, powered more cleverly, communicating smarter, and analyzed by advanced AI. They'll become an invisible part of our world, driving automation, efficiency, and a deeper understanding of everything around us. The convergence of science and engineering here continues to shape a future deeply influenced by these silent observers. Thanks for tuning in.